Hello everybody, I hope you are doing well. My name is Jacob Booe, and I will be presenting our fossil exhibit, The Geological History of Florida. Today I'm also joined by group colleagues and fellow students, Alyssa Anderson and Israel Rivera. Our first couple of exhibits contain tooth belonging to a couple shark species. Now, exhibit 1, we see the lemon shark. And it's important to note, each shark has a unique style of tooth. These features, along with you'll see many of the other exhibits, can help us not only characterize, but tell us the environments such creatures may inhabit it. For the lemon shark structure, we can see the tooth is pointed and long and has serrations along the sides. Now, as you'll see, there is also a black coloration towards the bottom of the tooth. This is called phosphatization of bone, and it occurs as fossilization happens in a phosphate-rich environment. And as you'll see, Florida has a rich history of phosphate. Now, as we know from the location of fossils from today's sharks and the fossil record, lemon sharks inhabit areas of shallow and warm waters. You can see on the map down here that lemon sharks inhabit coastal regions, primarily within the Gulf of Mexico and the Caribbean area. But today, it is one of our sharks found in Florida. Exhibit 2, the Megalodon. Many of you might have heard of Megalodon sharks for their giant size. We actually can see a lot of their teeth around the globe, including Florida. This specimen here, we see the tooth is approximately 1 inch long. Now, it's distinguished by its very large triangular shape. You can also see serrations lining the side of the tooth. As I stated earlier, this helps us identify the behaviors of the animal. In this case, serrations would indicate that it is a predatory animal. The Megalodon shark could grow over 15 meters during its lifetime. However, we do know that Megalodon sharks went extinct. This is because a lot of their prey inhabits shallow waters, and as climate changed, Megalodon were so large and unable to meet their energy needs that they slowly phased out of existence. As you can see in the map below, Megalodon inhabited plenty of regions across the globe. Exhibit 3 continues the trend of shark teeth. Below we have a whaler shark. Now you notice this is more similar to the lemon shark. However, instead of being elongated, it has more of a triangular shape with small serrations and a thicker crown. It is important to note that the whaler shark encompasses a broad range of species like bull sharks and sandbar sharks. Location-wise, global distribution is common in the West Atlantic and Western Pacific Oceans. This is again a fossil we see in Florida. In Exhibit 4, we see an echinoderm. Echinoderms are invertebrates that live in ocean environments. This particular genus, Rhinoclampus, has a very distinct body and has features that can help us identify it. As you can see in the picture, the echinoderm's body is more of an elongated oval. This helps us define and characterize it. In this case, it has a pattern of test on the top that resembles a flower, petals, and helps us identify it. In addition, at the bottom, the posterior towards the ruler, we see an anus, which is another identification or classification for this genus. Although the species of Rhinoclampus are extinct, We have occurrences within the Carolinas and Florida. This helps inform us of Florida's underwater past. As we know the geological history of Florida, it used to be submerged underwater mainly. We refer to this as the carbonate platform. However, as Cyclastic came from the Appalachian Mountains, it has produced the Florida we know today. Exhibit 5 is interesting. We actually identified a horse tooth. Now, as you can see in the picture, it has a orange to reddish tinge. This is a sign of oxidation, where the tooth has rusted. This horse tooth actually dates back to 23 to 5.3 million years ago. The structure of the tooth is extremely dense and designed for crushing. This helps notify us that this animal, the horse, is in fact a herbivore. As seen in the map below, this tooth was found near the Peace River. We know horses are not native to Florida and a lot of North America. Therefore, this would indicate that a land bridge between Siberia and Alaska allowed some of the horses to move to North America from Asia. This particular species has gone extinct. However, they have been redistributed in North America due to human influence. Continuing on to Exhibit 6, we go back to an invertebrate. This particular mollusk is a bivalve, going by the common name turkey-winged shells. The shell itself has its name because of its resemblance to a turkey feather. One of the main features that helps us is its brown colorations. In addition, its shape, its elongatedness, helps us indicate its environmental conditions. For example, the shape of the shell allows it to withstand stronger and more turbulent waters. Exhibit 7. While we were able to identify that as the mouth plate of a ray, it's hard to pinpoint an exact species. This mouth allows for rays, as bottom feeders, to suck and crush food as they filter through the bottom of ocean floors. They can also exist in freshwater environments. As I scroll down, we see that rays exist all the way back in the Jurassic period. Exhibit 8, the calico scallop. Now this is a return to the previously seen bivalves. Just like the turkey ridge, its features can tell us a lot about its lifestyle and the environment it lived in. For example, the calico scallop, while being thinner, would indicate that it cannot withstand as much strong and storm conditions. Therefore, we can say that it would live in environments more offshore. We also know that because of its shape, that the calico scallop is a free-living bivalve. Continuing to Exhibit 9. Exhibit 9 may look a little familiar or sound familiar, but this is actually the rib of a dugong. Dugong is a relative of the manatee. We know that dugongs within Florida have gone extinct. As seen in the photo to the left, the darker coloration is an indication of phosphatization. The location of such fossils can help us identify Florida's geological past. For example, the location of such fossils can help us support the claim that Florida was submerged underwater in its geological past. Continuing on to Exhibit 10, we have the ponderous arc clam. This is another example of a bivalve. The features of this bivalve are a smooth shell that is very thick. Compared to the turkey wing, they both have thick shells, but as you'll notice, a different shape. Both are suspension feeders, but while the turkey wing is more dependent on being attacked, the arc is a bit more mobile and doesn't like to burrow as deep. You could even argue that the arc clam could probably withstand even stronger currents than the other clams. Just some thoughts about the shape. Exhibit 11 is a personal favorite of mine. It is our first gastropod. As you'll notice, the shape is very unique compared to some of the other exhibits we have here in our museum. As you'll notice, an ongoing theme of our species is that the shapes and features can tell us a lot about their lifestyles and behaviors, whether that correlate to today or changed in the past, or even tell us about extinct species from what we know in the fossil record. You'll see that the bottom of the shell has a long tapered point. This is called the siphon. This is something we see with a lot of predatory behavior, species, excuse me. While we know that this gastropod is carnivorous, it doesn't always have to be a predator. Some can be opportunists, also known as scavengers, while others may hunt. If they hunt, they would use the elongated part of the bottom of the shell, siphon, to burrow into other clam shells and consume their insides. Example of why some bivalves might have thicker shells to help defend against gastropods as well. These gastropods can also be found around the globe and are not exclusive to Florida, however can be found here. Our final exhibit, Exhibit 12, is another gastropod. Our fossil is known as a tower shell. Shells actively filter water to obtain food, though some species in the genus can be suspension feeders that don't pump water. We see that these gastropods lived in waters up to 200 meters in depth. With the previous fossil record, we can see that some of these fossils are recovered in mainland Florida. This again references the idea and how fossils can help learn about geological past. We all hope you enjoyed our museum exhibit. Some of the things we wanted to teach you is how paleontology and the fossil records can be used with biology to help figure out behaviors of certain species, but also talk about the geological past of our areas, specifically Florida. With that said, thank you all. Have a good day.